1b is our next example. Again, I'm looking at the nth term test for divergence does not apply because the limit does go to 0. It's not geometric. It's obviously not telescoping. So the integral test is kind of my next option. So I'm going to establish that this is definitely positive for all n. It's also decreasing. It's also continuous. And because all three of those apply, I'm going to go ahead and go into the integral test. So I'm going to set this up as the integral from 1 to infinity. Now, the reason I'm using 1 is because I'm starting here at 1, correct? So make sure that you pay attention to what your index is starting at. And then I'm integrating 1 over n squared plus 1. This looks very similar to example 1a, but on top I don't have an n. So this is going to be a completely different strategy or diagnosis when it comes to integrating. So let's set up the limit. The limit as b approaches infinity, the integral from 1 to b. And then I've got 1 over n squared plus 1 dn. This is arctangent, right? This is not a regular u sub problem. This isn't a natural log. This is a scenario of u and a. So we would have u squared is equal to n squared, right? And u is equal to n. And then a squared is equal to 1. So a is equal to 1, du is equal to dn. So this is an arctangent. This is an inverse tangent diagnosis whenever it comes to integrating that. So we're going to keep the limit. Excuse me. I'm going to keep this limit here. The limit as b approaches infinity. And you have arctan. So we're going to say arctan. You can use tangent of -1 if you want to. And it's supposed to be 1 over a here, but 1 over a is just 1 over 1, so I don't have to have that. And then u over a is going to be n over 1. So it's going to be arctan of n evaluated from 1 to b. Again, I can't just substitute in and I can drop my limit at this point. I'm going to say the limit as b approaches infinity. And now I've got to plug in my evaluation pieces. So arctan of b minus arctan of 1. So ultimately, I'm looking at arctan of infinity minus arctan of 1. And what you're looking for is the angle, right? So what is the angle that would give me where I'm approaching infinity, and what is the angle where I'm approaching 1? Well, arctan of 1 you probably recognize as being pi over 4. Sine and cosine are the same. But it's real tempting to just assume that this doesn't exist, right? Arctan of infinity, I don't have that. But please be careful. Okay, I've got these two graphs. And I realized that I just copied and pasted that really quickly from a previous thing that I had done. But this is the graph of tangent. So whenever I ask for arctan of infinity, what I'm asking is at what angle is tangent approaching infinity? So this is tangent, correct? So I'm approaching infinity when the angle is pi over 2. This is arctangent. Arctangent of infinity is pi over 2. That is the angle, okay, that we are approaching, getting closer and closer and closer to. So technically, right, there's a 1 in here somewhere. So arctan of 1 is going to be pi over 4. That's kind of that area. But this is the graph of arctan. So don't assume that arctan of infinity is just this blank thing, right? No. Arctan of infinity is pi over 2. Arctan of negative infinity is negative pi over 2. Okay, so recognize the graphs and what those look like. So this is going to be pi over 2 minus pi over 4. So I'm getting pi over 4 as my limit, right? I'm approaching pi over 4. So I can confidently state that since I'm approaching a value, my series converges by integral test. It's important to recognize, though, that I'm not necessarily converging to pi over 4. Getting the value tells me what my integral is converging to, but my series and my integral are just enough different that I gotta be really careful with my understanding here. The behavior is the same in that they both converge, but I'm not necessarily converging to pi over 4 for this series. It's going to be really close to that no matter what, but that's not necessarily that number. So let's go ahead and make a quick note of that. We're going to say series not necessarily, it may be, we'd have to test it, not necessarily converging to pi over 4. But I do know that the series converges based on the integral test.